Well, good morning, ladies and gentlemen. Or I forget, you can watch this anytime you want. So it might be afternoon or evening. Anyway, I hope you're having a great day on this Friday before Palm Sunday weekend. Next weekend is Easter, one of the greatest days in the history of mankind. And so this Sunday is Palm Sunday when we remember that Jesus entered Jerusalem. So I hope that you are celebrating and that you are attending church online. I know you can't get there, so make sure you find a place to go and watch service. You know that you're always welcome, as I've told you before, to join us if you don't have your own church to attend online or if they're not streaming services. rockchurch.com is where I'll be watching, so I hope that you are too. All right, so let's jump into, you can see the DNA looks really long for today, and it's not a difficult question. There's just a lot of words, so why don't you pause the video, take a minute and copy down the DNA, learning targets, and homework, and then come back after you've written it down. All right, hopefully you had a chance to write that down, and let's go ahead and read through it together. Some sulfur dioxide released into the atmosphere is converted to sulfuric acid, according to the equation below. And then the balanced equation is given to you there in blue. Determine the mass of sulfuric acid formed from 90 grams of sulfur dioxide. So you're going to write, the first thing we're going to do as usual is write our known and our unknown. And if you take a look here, right, we're asked about sulfuric acid. Now if you remember, acids start with hydrogen. So this is our sulfuric acid. That's our unknown. What we know is we have 90 grams of sulfur dioxide. And so here we have our sulfur dioxide. So we're going from mass of sulfur dioxide to mass of sulfuric acid. So you're going to do a mass to mass conversion. Now you should have your stoichiometry chart as well as your periodic table. And you're going to go from mass of A to moles of A, moles of A to moles of B, moles of B to mass of B. That's step one. So I'd like you to solve that first and then come back, pause the video, solve mass of A to mass of B. We'll check your work and then we'll go on and do the percent yield calculation, which was the new calculation we learned yesterday. All right, so pause the video now, set up your known and your unknown, and solve from mass of A to mass of B. All right, so hopefully you did your best and you solved that. What you should have done was this here. Oops, I put too much up. That's okay. Mass of A to moles of A, moles of A to moles of B, moles of B to mass of B, with sulfur dioxide being our mass of A. We know we have 90 grams of that, and we're trying to figure out how much sulfuric acid would be made. So our job is to figure out grams of that. So that is a three-step conversion. So we start with our known. Here we have 90 grams of sulfur dioxide was given to us in the problem. And in order to go from mass of A to moles of A, you know you need molar mass. So you should have used your periodic table, added up 1 sulfur and 2 oxygens, and then you set your molar mass with grams on the bottom and moles on the top. So your first conversion factor should look like this. 64.06 grams of sulfur dioxide is equal to 1 mole of sulfur dioxide. Hopefully you got that right. If you got the number wrong, pause the video, go check your periodic table and figure out what is it that you're doing wrong and not getting you the right answer. If you're good to go and your work checks, those should cancel out, and we go on to our next conversion factor. Now in our next conversion factor, right, we are going from moles of A to moles of B. And the only way to make a mole to mole conversion is to go back to the balanced equation. This is our balanced equation, so we're going to look for the coefficients. Notice that on sulfur dioxide we have a coefficient of 2, and on sulfuric acid we have a coefficient 2. So the ratio, the mole ratio, is that for every 2 sulfur dioxides we're going to get 2 sulfuric acids. right? So that's what we're going to use for our conversion factor. Okay, so we're going to put on the bottom the sulfur dioxide so that they will cancel out, and the sulfuric acid on the top. So that's what your conversion factor should look like. Take a look at that. Take a look what you did, and I'll erase some of this. And if any of that was confusing, just go ahead and stop the video and rewind as usual. If you're ready to move on, moles of sulfur dioxide cancel out, and we've got one last step left, right? And on our last step, we're going to go from moles of B. Remember, B is our sulfuric acid, which we already have here. We've got moles of B, and we're going to go to mass of B. The only way to get from moles to mass is to use the molar mass. So you need to go to your periodic table and add up all of this. 2 hydrogens, 1 sulfur, and 4 oxygens. You're not going to do anything with this 2. You're not multiplying it by 2. You've already used the 2 right here. You don't use it again. You only use it in the mole ratio. Molar mass is always the mass of only 1 mole, no more than 1 mole. So 2 hydrogens, 1 sulfur, and 4 oxygens. Once you've added those up, continue the video. Pause until you've done that. Okay, so once you have your molar mass, you're going to go ahead and write it in. We put moles on the bottom so that moles of sulfuric acid would cancel. And you should have got 98.08 grams of sulfuric acid. If you haven't done the calculation, pause the video, take out your calculator, calculate this all, get an answer before you see the answer. All right, and what you're putting into your calculator is you've got the 90 grams of sulfur. You're going to divide it by the 64.6 grams of sulfur dioxide, multiply by 2 and divide by 2, but because those cancel out, you could actually skip that step. But if that confuses you, just go ahead and multiply by 2 and divide by 2, and then multiply by 98.08, and you should get 137.8 grams of sulfuric acid. And if you're taking a look at the numbers and wondering why do I have 4 numbers, it's because go back to the known, and you'll see that when we had our original, we had 1, 2, 3, 4 numbers. So our answer gets 1, 2, 3, 4 numbers also. All right, hopefully you were able to make a big cha-ching on your paper to show that you actually got that correct. I prefer my cha-chings in red. All right, but we're not done. That's just the first step. We have figured out what's known as the theoretical yield. So in theory, if you were doing this reaction and you had 90 grams of sulfur dioxide, right, you should make 137.8 grams of sulfuric acid. So this is our in theory. This is our theoretical yield. But we saw in the DNA that there was a second part to the question. It says, what if, right, what if 123.47 grams of sulfuric acid is produced? So this is what is actually made in the lab. Now we have 2 different values. We have the value that should have been produced, and we have the value that was produced. So this is what should have been made if it was a perfect world and there's no mistakes. But this is the real world, what was actually made. So that's where percent yield comes into play. The reason we need percent yield is because it gives us the efficiency, right? Percent yield tells us how good is this reaction. So we compare the actual yield to the theoretical yield. So that formula, taking a look at your notes from yesterday, if you don't have them out, pause the video, go grab them. All right, taking a look at your notes from yesterday, you'll see percent yield is equal to the actual yield on top divided by the theoretical yield on the bottom times 100, because every percentage is the part divided by the whole times 100. So, with that said, let's go ahead and set this up. The part is going to be what we actually got in the lab. So 123.47 grams will go on top because that was what actually was produced. The 137.8 is what should have been produced in a perfect world. So that goes on the bottom. Take your calculator and go ahead and divide 123.47 grams divided by 137.8 grams, multiply by 100, and you should get the answer to 2 decimal places, and write that down. All right, our answer is 89.60 grams. I'm sorry, 89.60% yield. That is a really good experiment. When you can get an experiment way up there in the high 80s and 90s, it is very efficient. Remember, that's what percent yield measures. It measures its efficiency. All right, ladies and gentlemen, well, that's it for our DNA today. You do not have a separate lecture. We have lectured all the way through stoichiometry with what we learned in week 10. Those of you who practice limiting reagents on, what day did we release that? I think it was Tuesday or Wednesday this week. I can't recall. And then yesterday, oh, I'm sorry, it was Tuesday. Wednesday we did percent yield. And then today, just another practice percent yield problem. And we've got some practice stoichiometry problems for you. Make sure you're writing down these notes, upload them into the assignment spot on Teams, and then your homework under the separate homework spot. Every time you upload an assignment and the assignment is completed and done correctly, that's 20 points. All of those 20 points are going to get added up and put into your grade for your semester grade, since we found out that we are not going back to campus for this school year. All of your schooling is going to be online. So make sure that you're taking advantage, especially those of you who've been emailing me, hey, I never got to turn in my week 8. Hey, my binder never got put in. All of those things, issues that we're going to try to resolve but not sure that we can. You want to make sure that you're doing all of the work that's been placed online. So starting with week 10 through the end of the semester, which is week 18, do every single assignment to get your grade up if you're in need of that. Also want to mention, because I know that a lot of families are going through difficulties right now, if your family is having trouble financially and you guys are in need of help with food or other kinds of resources like that, please send me an email message. As you know, where I work at the Rock Church, we have resources. We're giving out food every Tuesday and Thursday to families who are in need. So if you want that information, just let me know, or go to the church website, rockchurch.com, and that information is there for you. So no strings attached, no obligation. If you're in need, we want to make sure to help you. And also remember, the school is giving out lunches, packets. Just drive on by with your parents, or you can walk up to the school and they will give you breakfast and lunch every day. I'm not real sure about the times on that. But if you want to call the school to find out, or go to the school website, that information is also on there. And I'll take a look for the next video to get that information to you. I can be reached on Teams. I can also be reached via email. I can also be reached on, I've been getting some messages from people on Instagram. Any of those places, you are welcome to contact me. I hope that you are well and your family is well. And I will see you again on here next week. Bye-bye.